This video is for Math 111, and this is about completing the first project. So we'll have two projects over the course of the term. And based on what past students have told me, very few people have done something like this previously. And so that tends to make people very nervous about it. Some people just decide not to do it entirely. That's not a good choice because this project is 20% of your final grade. So if you choose not to do a project, that takes your grade down by 2 letter grades. And if you choose not to do either of the projects, then you can't pass the course because they constitute 40% of your grade. And 100 minus 40 is 60, which is not a passing grade. Okay, so let's assume then that you are going to do the project. The project itself consists of 2 word problems. Okay, I'll get to the content of the problems in just a minute. First, I want to talk about the tips for completing the projects. It's very important that you understand what I'm looking for here. So what I'm looking for is I want you to solve the word problems that are on the project, but I also want you to explain your answers. Okay? So for instance, the first thing I asked you to do is to represent the problem algebraically. So you need to explain to me why the equation that you give to represent the situation actually does represent the situation. Okay? So if somebody else does it for you and you have no idea where it comes from, that's going to be a problem. Okay? So it's important that you understand what it is that you're writing down for your answers. So that's the first thing, is that I expect a written explanation of the process of solution. And your explanation, so now I'm looking at the tips for completing the projects, your assignment should be typewritten. Okay, that means using word processing and print it out. Okay, let's see, if you are using the computers on campus, most of them have Microsoft Word available. Okay, if you are using an Apple has its own word processing, and there's nothing wrong with it. It works just great. So there are also equation editors available during, during this period of time where we're not having in-person classes. I've kind of eased off of the requirement to use an equation editor. If you can use one, that would be great. Makes it a lot easier for me to read. If you are not familiar with that and can't figure out how to do it, that's okay too. I'm not going to take points off for it. But your paper should be typewritten and printed out like a report in paragraph form using complete sentences. That's what I'm looking for. I'm looking for a report on your solution of the problem with a complete explanation of why your solution is correct. Your explanation should be interwoven with the mathematics. Okay? So math papers, when they're written, typically have some, paragraphs of explanation. You might see some math notation in there. And then when they get to the big equation, 3x plus 7 equals 19, then they set it off, okay? And then maybe you'll have a solution showing, a solving of the problem. Now, also, what would actually be better here, now that I've written this down, is to actually say what you're doing, right? Then let me use a full sentence here. Then we subtract 7 on both sides. Okay, then we'll have 3x. And then go ahead and show that step equals 12. Then divide on both sides by 3. Okay, then you'll show that. And then there's your solution, x equals 4. and then maybe you'll go into the next part of the project and you'll have some more writing to set that up. Okay, so that's the goal, is that you should have some explanation to set up whatever mathematics is about to happen, then show the mathematics with an explanation for how it's changing, and then when you arrive at some stopping place for your math, then you can pick it up and say, now that I know this, I'm going to do this with it. Okay, so that's what I'm looking for in terms of these assignments. Now, if you're not sure if what you're doing is what I'm looking for, I'm happy to look at it. You can email it to me, and I'll be happy to take a look at it and let you know whether or not it is correct, what I'm looking for. I won't pre-grade it for you, but I will let you know if you have errors. Let's see here. What else? Your assignment should be neat and organized. Your answers should be coherent and easily understandable. You should demonstrate understanding of the question. The concepts on which the problem is based should be clearly presented and explained. Your method of solution should be mathematically valid. All of these things are the things that I'm looking for when I'm grading your assignment. And a lot of them have to do with me giving this assignment and people going and getting the answers from somebody else and then turning it in as their own work. That's what a lot of this is geared to try to prevent. I'm not saying that it prevents all of that, but it does cut way, way, way down on it. Another thing that cuts way down on people copying each other's work is that if I catch you copying other people's work, you will fail the course, okay? And I assume that that's not something that you want to have happen. So while I did say that it is difficult to pass the course if you don't turn in an assignment, you can still pass the course if you don't turn in one of these projects. It's not easy to do, because you have to get an A on everything else to end up with a C if you don't do one of the projects. But what I'm saying is, if you copy somebody else's work, chances are pretty good that you're going to fail the course. So I don't recommend doing that. Okay? I do recommend asking questions. I like to talk about these problems. That's why I give them on the assignment. Okay? So I'm happy to talk to you about these problems. What I'm going to say right now is just sort of an introduction to the problem. If I went through the whole problem, I don't feel that it's that helpful, because I've done that in the past, and if people haven't gotten to that point in the problem, then what I'm saying just kind of goes in one ear and out the other. So my advice is get started on the problem. If you get stuck, then ask questions. You can talk to me, you can talk to Celeste, who's working the math lab this term. Those are both good options. You can talk to other people that you know, or tutors, but I would be very careful with that, because if somebody just gives you an answer and you can't explain it, then you're going to lose points for that. And I don't give out very much credit for work with no explanation. Okay, so let's look at the problems themselves. The first problem is a rate, time, and distance problem. Rate times time equals distance. So in this problem, you're given some information about the rates, about the time, and about the distance. Okay? What it is, the distance each way is 276 miles. So you've got this trip, 276 going, 276 coming back. Okay? The total time is given as 9 hours and 45 minutes. But the speeds, or the rates, are different. Looks like the person was going, let's see here, rate returning was 21 miles per hour faster. Okay? So the returning rate is going to be faster than the rate going. That means you're going to use less time coming back and more time when you're going there, right? Because you're going more slowly, it's going to take longer to get there. And I mention that because one of the most common mistakes that I see people make is just to take this 9 hours and 45 minutes and split it in half and say, well, it took half the time to get there and half the time to get back. That's not what's happening, okay? If you're going more slowly when you go there, it will take you longer. It will take more of these 9 hours and 45 minutes. And if you're going faster when you come back, it will take less time. It will take fewer than half of the 9 hours and 45 minutes, okay? So that's a very important thing to remember. So let's see here. This is the basic setup that you're going to be working with. The ideas are, essentially that the rates are related to each other. And this rate is 21 miles per hour faster than this rate is, so you can relate those two to each other. What else? Oh, if you have two different times, and together they have to add up to 9 hours and 45 minutes, I would recommend turning that into a decimal. 45 out of 60 would turn this into a decimal form rather than hours and minutes. And I think I'll just leave it there at this point, okay? And if you have trouble getting started, let me know. We can talk about it some more. If you get started and get stuck, let me know, and I can try to help you. So I think that's it for problem 1. And let's take a look at problem 2. Problem 2 is more of a geometry problem. We've got this monument with 2 cubes of granite. So one of the key factors about cubes is that they're the same length, width, and height on all sides. Okay? So there's really just a single variable that we need to describe all of the dimensions of this block. Okay? If this is x, then this is x, this is x, this is x, that's x, and so forth. Okay? So there's the big block, and then on top of it we have a smaller block which sits on top of it something like this. Okay? So that's what it looks like. The problem gives us information about the total height. Okay? And again, this one is bigger than this one, so they're not going to be half and half, just like what's happening in problem 1. But we know that this and this together have to add up to be 10 feet. And then it says all of the exposed surfaces, which are all of these surfaces all around there. The bottom is not included because it's not exposed. This surface here, but not what's being covered by the smaller cube, okay? And then all the surfaces on the smaller cube that are exposed as well. Okay, so I won't get into that too much. That's part of the project, is to figure out what's exposed and what's not exposed. So those are the 2 key pieces of information. You've got information about the total height of the 2 blocks together, and then you've got some information about the total of all the exposed surfaces. So again, if you have trouble getting started, let me know. I'll be happy to talk to you about it. And if you get started on it and get stuck, again, I can try to help you out with that. But in any event, I think that this is about enough information to try to get started with this. As always, with any of these assignments, whether they're in the textbook or whether it's one of these projects, if you get stuck, if you have questions, please let me know. I'll be happy to talk with you. Thanks.